Hey everyone, we're Wolf of Wall Street. I'm Ravi.
This is Rigvid.
And this is David.
So the motivation for our project was that manual technical analysis of individual stocks takes a lot of time, and automating this process with neural networks would lead to better accuracy for stock picking, and also allows us to use a larger data set because if you're manually doing it, you choose points to analyze. And also learning technical analysis takes months, and training and using this neural net would take less time.
So some of the goals that we were trying to achieve with this model is using the machine learning model to predict the future prices of stocks given historical data set, also helping to mitigate/reduce the risk of purchasing individual stocks within a portfolio, and then lastly going to allow average individuals without the knowledge or the know-how in the stock market to participate and build a portfolio for retirement.
So the data we chose was the Apple stock from December 1980 to April 2024, and we split this data set into training, testing, and validation. And we also used the close price as our feature, as it seemed to work the best.
So for our baseline, we use an R and N base model, so a recurrent neural network. Some of the layers that we use are going to be a simple an R and N layer, which is basically using the relationship of the last element to predict the next future element, which as you can see in our code, we have return sequence equaling true. Then we have our dropout layers, which helps with preventing overfitting of the data. And then we have dense layers, which helps combine the prediction information from the previous layer with helping with the to create the new feature/prediction. And then with our baseline, we got our baseline model from Geeks for Geeks tutorial on how to develop a basic RNet. So with the baseline model, this is the performance of it. As you can see, it is kind of going along the route of our validation set. We have a root mean squared error of 4.418. We wanted to get it a little bit closer as far as the overlay of it, and which we use our next model to describe and get better data.
For our next model, we built off of the simple RNN model, and we built off of it using an LSTM. And basically, what an LSTM it does is that it uses gates to manage information flow, allowing them to remember selective data points or forget selective data points that might cause the data to be skewed or the next day prediction to be skewed. LSTM makes for a better understanding, works better for long-term data sets just because it's able to fix problems known as vanishing gradients, which basically for a simple RNN, it struggles with long sequences in their memory. As long sequences are implemented, the data or the memory becomes more and more ineffective. And you can see the improvement between the model as we go from 4.4 to 1.9. And you also see the red line, which is our prediction, and the green being our actual. And the data on the right shows a better following of that green line.
Thank you.
Thank you.
Thank you.